Okay, as usual, let's do a very quick recap of what we said last time. Okay, basically we talked about polymorphism, dynamic binding, and also typecast in the previous lecture. Now we just want to go a little bit deeper, applying these concepts to two contexts. One is about how do you handle polymorphism and dynamic binding for method parameters. That's what we talked about last time. I will recap that quickly. And we go on to return values for the methods. And that will actually draw a closure on this particular topic, and then we go on something new. Okay, also relevant to inheritance. Okay, so let's see the class we have over here. We have a class called Student Management System over here. And we simply declare an attribute SS over here. The type is simply students array. Again, if you want to see a static type, only look at the declaration. That means every element of the SS will be of static type students. Okay, that's what we talked about last time. I assume you're okay with that. Okay, so the first question is very easy. So you want to know every element for SS should be of static type students. That's how you see. And then what we want to know is how do we pass parameters or arguments at the runtime when we run the code, when we call the method. Okay, let's go to the next one. This is the exercise we did all together. Let's just do a few of them just as a review quickly. Okay. Let's have a look at this one particularly. Let's say we have a look at this line here, okay? Now, how do we judge if this line should compile or not? First of all, can we actually call add students on SMS? That's the first question. The answer is you can. How do you judge? Look at the static type for the context objects, which is student management system over here. And now, does this particular class declare a method called add students? Yes, it does. It declares add students over here, right? That's why that part over there compiles. Let's go further. Can we actually pass S1 over here? Would it compile for this one here? Are you sure? Yes? No? Yes? Okay, what's the type that's being expected from add students? Student, right? You can see that over here, add students is expecting a students. And S1, you can think about S over here is the parameter. Implicitly, because of call by value, what we are doing over here is S is assigned to the arguments S1. Okay, that's basically the assignment that's boiled down into. We know that for S1, the static type is students. And for S, it's declared as students. And student is a descending class of student. That's why that will be okay. Okay, let's see one that wouldn't be okay. So the one we just look at, that will be okay. So that's check mark. What about the one over here? Let's highlight in blue. What about this guy here? We are calling a different method on the same context objects, right? First of all, SMS has the static type student management system, which does declare a method called addRs, which is here. Okay? Now, can we actually pass S3 over here? Yes or no? Okay, no is correct. However, why? You got to be very careful with this. This would not compile simply because implicitly we are trying to assign S3 into the parameter. So what's the parameter? addRs is over here, RS. Okay, RS is assigned to S3. And what's the static type for S3, first of all? S3 was static type students. So I put student here. And what's the static type for RS? It was declared exactly over here, that's resident students. Now the question is students a descending class of resident students? No, so you wouldn't compile. Okay, that's why. That's exactly what I would expect you to answer on Monday. Okay, just make sure you get well prepared for this. Okay, we're okay with this. Let's go a little bit further over here. So this is new, okay? And we'll go back to polymorphic array in just one moment. Now we have enough time to have some discussion. Basically, when you go to the slides, it's actually 4 slides. I'll talk about all of them all together so you can see the comparison. So you will see that when you go through the slides, so we have talked about all these already, so I don't need to worry. When you actually look at, starting from this particular slides over here, there are 4 slides having similar examples. Let's just see the difference between them. Okay, it will illustrate quite many things. It will review quite many things we talked about so far. Let's focus on one thing at a time. First of all, let's compare to see the similarity between the 4 examples. In all the examples, we declare students S, students S, students S. That means we're talking about the same variable of the same static type, students. That's the static type we're talking about, okay? And the dynamic type is actually different. In the first case, the dynamic type is simply a students. In the second case, dynamic type is non-resident students. In the third case, it's a resident students. So the static type is the same for all the three cases, but dynamic types are different. Oh, nice. Wow, 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 wow. Please, next time, don't be shy. Just tell me, right? Okay. Let me repeat very quickly, okay? As you can see the color here. Again, you can see all the 4 examples over here. We got 1, 2, 3, and 4. In all the cases, we're declaring this, you know what? I can just undo. Do it again. In all the 3 cases, you can see student S, and student S. Okay? So these are the same static type for S, the same. However, dynamic types are different. Okay? Let's highlight them, like what I did before. So here you can see the first case will be students, dynamic type, and the second case, non-resident students, and the third case is resident students. Okay, dynamic types are different, but the static type are the same. Now, what we want to do is, we want to do some cast. But why do we want to do a cast? Let's see the following. Let's have a look at this line here. In all the cases, we are trying to call sms.addRs, sms.addRs, sms.addRs. Let's review what we just said. Is the yellow line going to compile or not? The yellow line, okay? Hopefully you know why, right? Let's review very quickly. This simply will not compile. You can see the argument over here is S. S over here. The static type is simply just students. And what is being expected from addRs? Let's look very quickly back to the definition. addRs is expecting RS of type resident students. Right? Implicitly, we are really doing RS is assigned to S. We know that the static type for S over here is students. RS, on the other hand, as you can see over here, is resident students. Right? I'll put RS. Now, we know that student is not a descendant class of resident students, so that's why it wouldn't compile. Now, as we said before, how can you temporarily modify the static type? We do a cast. Okay? Now, there are 2 ways for you to do this. I'll show you the, we have 2 kinds of cast, either anonymous cast or named cast. Okay? Let me just do the named cast for you, just as an illustration quickly. So now we know that we just cannot pass S directly because that static type doesn't match. But I can do the following. I'll write it down here in red. I can say resident students, I would say temp, temporary. Is assigned to, I want to cast into resident students, I want to cast S into it. And then after that, I can say SMS dot add RS, and then I will pass temp over here. Now let's examine these 2 lines to make sure both of them compile as far as compilation is concerned. Let me call this line number 1 and this line number 2. Is line number 1 going to compile? Well, to know if a cast will compile, you just have to know, are you casting upwards or downwards, right? In this case, upwards or downwards? Downwards, right? Because S over here, static type is simply just students. And from students onto RS is downward casting. So that will compile, no problem. And then that means the new variable we're creating over here, not new objects, new reference to the same objects. Temp is now of static type RS. And now, when we try to pass temp into here, now that should compile, right? Because now temp over here, the static type is resident students, which will match the expectation over here for resident students. Okay, with a cast, that's okay. Any question for this? Okay, right? So this is one way to write it. You can simplify this into a single line. And the way you can do this is by whatever I put on the green. I'll highlight it to you. Here, I can say SMS over here, dot add RS. Now I can say S is over here. Okay? When I pass that into the arguments, I can simply say, now let's do the cast over here. So that would be just a single line. So I'm saying that this single line over here, is completely equivalent to these 2 lines. They are completely the same. doing the same thing. The only difference is, in this case over here, with the name, we're just creating a temporary variable to capture the new reference with a new static type. On the other hand, for the first case over here, we are not really giving a name to the cast variable. We simply say we're passing S and then give the resident students. Guys, are we okay? In case you cannot see this very clearly, let's see the slides. Okay? That's exactly what you have to write. Okay? Basically, you say sms.addRs. Now, rather than passing a single variable, just S, which wouldn't compile, you say the cast version of S into resident students. Questions? Mm-hmm. Yep.
What does that say? Two line zero versus the thing?
You mean this one here?
Yeah, what is the...
We're just trying to do a cast over here and then save that into temp and then pass the temp as the arguments over here for addRs. Okay, that's what we're doing. And that can be simplified into just a single line over here, which I'm trying to show you, hopefully a little bit more clearly over here. Okay, any questions? Are we okay following? Okay. So this line here, after the cast, actually is going to compile for this particular method call. Again, you have to know how to really judge every step, if every step should compile. Okay. Now, let's go a little bit further still. We know that if we simply apply this line over here to say sms.addRs. So now let me ask you the following. Let's say for this particular example over here, okay? Now, if I try this particular line for every case, this case here, this case here, this case here, because the static type for the student's objects is just the same. So the same cast will just compile. Dynamic type is not relevant when you talk about compilation, simply not, okay? Now, let's consider case by case. Let's say for this particular case over here, if I try to, rather than this line here, which wouldn't compile, if I try over here, sms dot add rs, and then I'm trying to cast into resident students from S. This will compile, but my question to you, is this going to give me any class cast exception? Is it or is it not? Well, when we talk about class cast exception before, let's think about intuitively. You can refer to the more details from the last time's lecture. When you want to know if there's any class cast exception, you have to bring dynamic type into play. So at this particular line, what we have is, for S over here, what is the dynamic type? Students, right? From here. It is simply a students. And what does it really mean? When I say I want to cast a student's object into a resident student's, that means I can do something that I can expect from the resident students on this particular student objects. For example, can I do set premium rates on the student's objects? No, I cannot. So that's why you have runtime class cast exception. Right? That's something we already covered last time. Right? Question here. Okay, so in this first, yes, go ahead.
Can you just repeat what you just said?
Of course I can. So now, have a look at this. Over here, think about what this is trying to do. When we say rs in parentheses s, we are trying to cast this particular variable, whatever object it is pointing to, into the type resident students. That means after the cast, we can try to run any methods we can expect on this particular cast type, which will be the new static type, right? So now, what can we run? What can we expect from rs? For example, set premium rates. Let's say just premium rates over here. But remember, S is actually just pointing to a student's objects dynamically, which means when you try to do premium rates, no, it cannot be satisfied by a student object, right? That's why. Okay? So this will be compilable, but class cast exception. Let's now consider the same line, which will also compile, but for the second example. Let's say second example is over here. Now you can see the dynamic type is different, non-resident students, right? Now, if I try the following, I say sms.addRs, and now I want to cast S, which has a different dynamic type over here, into rs. Can you apply the same reasoning and tell me, even though it compiles, are we going to run into class cast exception? Are we, or are we not? So you can see S over here, dynamic type. Again, if I ask you whether there will be dynamic any class cast exception at the runtime, you should definitely talk about the dynamic type. Dynamic type over here is non-resident students. Now, if I try to cast this particular variable over here, which is pointing to a non-resident students, into RS, part of the expectation for RS will be premium rates. Does this have premium rates? No. So, class cast exception. Be careful. Okay? Guys following? You can see for example 1, example 2, we're basically doing some compilable cast, but the cast type we are cast into cannot be met by the actual dynamic type of the objects. But when will it work? Well, it will only work if you're trying to cast into something that can meet your expectation. For example, let's see over here. Example number 3, over here. Okay? If I try the same line, SMS dot add RS, and then I will simply pad RS over here and S. Now, for sure, it's going to compile. Are we going to get class cast exception this time? No, right? Hopefully not, right? Okay, good. Let's see. Again, the same reasoning. So S over here has the, let me be consistent with the color. Let's use pink. Okay, S over here has the dynamic type, which is resident students. Now, resident student has just going to meet all the expectation for itself. So it's okay. So no class cast exception. It's going to be fine. Okay, hopefully you can compare these 3 examples to strengthen your understanding. Now we're just considering the same concept from last time, but now in a different context about argument passing. Okay, question before I talk about last example.
What it's going to do is it's going to put RS equal to whatever the argument is, right?
Oh yeah, exactly. Yeah, if, I'll just refer you to where you should look at. If you look at the slide or the previous page, you can see the definition for add RS over here, and then simply just assign to the array, which we talked about last time. Okay, yeah. Good. Okay, last one. Last one is going to be interesting. Okay. Now, I already got this line over here for you. Okay, the same line, resident students. Now we have a different variable. Okay, let's go over the static type and dynamic type, etc. For this one here, it's NRS of static type non-resident students. So now static type is different. Okay, and the dynamic type is non-resident students. Okay. Now, question number 1. If we simply just try this particular cast, is it going to even compile? Okay, how do you judge? Go ahead.
If you want to check something compiled, you're going to have to check the static type.
Yeah.
And with the casting, it either has to be upward casting or downward.
Downward casting, and in this case, it's neither, right? As you can see over here, the NRS has the static type over here. We know that it's non-resident student. I'll say NRS. Now, can we cast NRS into resident students? No, they're actually sibling. Remember the hierarchy, right? It's neither the ancestor nor the descendants. Okay? So now, does it compile? No, because neither upward nor downward. So it wouldn't even compile. So on Monday, hopefully you're really clear. You have to know very clearly, giving you a cast, is it going to compile? If it does not compile, why? If it does compile, why? If it does compile, does it run into class cast exception? If it does, why? If it does not, why not? Right? So these are the 4 questions you got to keep asking yourself, right? Okay, good. Now, let's go on. Now, I want to just draw your attention. We already talked about this polymorphic array. I'll just try to give you a little bit more perspective. Especially, remember one of you guys, I forgot who, asked me why are we doing inheritance, okay? The only way you can really appreciate inheritance is by comparing with the case where you don't have inheritance. I want to show you some slides over here. I do have some hyperlink. I believe it's working. Okay, so we already talked about these 4 cases, right? So you can refer to the slide with more details. Now, why inheritance? Now, let's just go back 3 or 4 lectures before. Let's go back to when we have no inheritance. When we have no inheritance, which means students Oh, sorry, we only got two classes. We got resident students and we got non-resident students, right? We got lots of code duplication. And how can we manage all the students all together? We simply can, the only way we can do it is by saying we got two separate arrays, right? One array for resident students, another array for non-resident students. That's what we said. That means for every operation, for example, if you want to register for all the students for a particular course, how many loops do we need to run in this case? You need to run two loops, right? You want to run one loop for the resident students, another loop for non-resident students. That's what you have to do. That's without inheritance. Because you simply have no connection whatsoever between these two classes, between resident students and non-resident students. Okay? But now with inheritance and polymorphism, we can get away from this by collapsing them into one single array, simply because these two classes have a common ancestor called students. Okay? Now, just give you more perspective. So this is a really like a toy example. We only got two kinds of students. In a more realistic system, let's say you got 10 different kinds of students. Without inheritance, you need 10 different arrays. For register all, you have to write 10 different loops. That's not something you want to do as a developer. So what we can do when we have inheritance is, so now we come to the context where we do have inheritance. So now we got student class on the top, we got two descendant classes, right? So all we got to do is we can say we declare only a students array, only a single one. It doesn't matter how many kinds of students you have. You have 100 kinds, no problem. Just make sure all those 100 kinds of students are descendant classes of the student class, right? And then here you can say we got student class over here as a static type. Dynamically speaking, any descendant classes of the student class can be put into the array. Okay? All right, so now how do we implement this register all over here? How many loops do we need? One. And we just got to call the register method. Okay? All we got to do is to call the register method here. Now you can see that students just run a loop between from the beginning to the end, and then we simply say students at position I dot register. Okay? Now let's the most important line is this line here. When you say students I dot register C, okay? Again, let's talk about compilation versus runtime. Okay? Compilation-wise, is this line going to compile? When I say students at position I dot register, why would it compile? What's the static type for students at position I? Static type. Students, right? Does the student class have a register method? It does. You can look back at your slide. Okay, just wanted to show you. Yes. So that's why it compiles. But now, at the runtime, which version of the register is going to be called? Depends on what kind of student you're talking about, right? Okay, good. Just want to make sure that's clear to you. Okay, good. So this is much simplified, and also it's very scalable, depending on, doesn't matter how many students you have. One more thing to point to you. Okay, let's go back to iPad. Okay. Now, I want to just go over, okay, the structure over here. So this block of code simply just try to initialize a runtime structure like this. Okay, I'll just highlight to you the importance stuff because we already talked about it. Okay, all I want to show you is you can see over here we have RS and NRS. We got two student objects. One has dynamic type resident students. The other one has dynamic type non-resident students. Okay, and then we simply try to add the students RS and NRS. Right, and I'll leave as an exercise for you why these two lines should compile. Okay, the same analysis. I'll leave that to you. Okay, after executing up to here, what we have is we got SMS, a student management system objects. Number of students is simply 2, the count. It's referring to an array over here. The first position corresponds to the first object we just added, which is a resident students objects. And the second position over here is referring to a non-resident students objects, right? Now, how can we check this to make sure that's really the case? You can use instance of. Okay. Now, let's have a quick look. That's also something you want to make sure you are comfortable with. Okay. Let's have a look at the first one. I'll tell you which one to look at. Can we just have a look at these three over here? So you can see that over here, I got a common prefix over here, SMS.ss at position 0, and the same here, and the same here. And for all of them, I'm trying to use the instance of operator, instance of, right? Now, I got 3 different cases for you. All you gotta tell me is whether that'll be true or false, right? Instance of will just tell you true or false. So what does it really check? Instance of, it's not really checking static type, gotta be careful, it's the opposite. Instance of is basically like a runtime check. What's the purpose of an instance of? Before you try to do a cast, you want to run the instance of to make sure the object you're trying to cast into is at least a descending class of the type you're trying to cast into, right? You can refer to the slides from last time, okay? So that you wouldn't run into the class cast exception, okay? Now, basically what it will do is, it's gonna ask the following question. When I try to run this particular line, let's say this one here, the pink one, just say for this guy here. What I'm asking is, for this particular expression here, whatever object it is pointing to, the dynamic type, what's the dynamic type for SMS at SS at position 0? Dynamic type. Position 0, right? Resident students. Okay, I'll just put dynamic type over here, resident students. I'm simply asking the following question. Is the dynamic type a descending class of the right-hand side? Is it? Yes, right? Resident students, dynamic type is definitely a descending class of students. So this will just be true. What about the second check? Second check. Well, the same object over here, SMS at position 0 over here, that will be dynamic type resident students. Is resident students a descending class of resident students? Right, that will be true. What about the last one? Well, in this case, the same object here, dynamic type is still resident students, but now is resident students a descending class of non-resident students? No. Okay? Hopefully you get an idea. Let's try even more. Okay? Let's look at the right-hand side of the iPad. Let's say I try to do basically the same kind of check over here. But now the objects I'm talking about is different. It's the objects at position 1 as opposed to in position 0. Now in this case, first of all, what's the dynamic type for SMS.SS at position 1? Well, exactly, that's position 1. It's pointing to exactly this object here with non-resident students, right? Let's write it down. That means over here, the dynamic type is simply non-resident students. Now you can see I'm doing the same check. Let's see if the true and false might be different or the same. The first one, when I say SMS.SS position 1, instance of students, is it? Right, because NRS, dynamic type, is a descending class of student, yes. Now, what used to be true, is it still going to be true for this case? SMS.SS at position 1, dynamic type NRS. Is NRS a descending class of resident students? No. So you can see this highlights the difference between the two, right? I can highlight this. This guy here will be true, and this guy here will be false. Okay, one more. What about the next one? The same object here, instance of non-resident students. Well, is NRS a descending class of non-resident students? Yes. Okay, that will be true. Okay, true, true, false for the left-hand side. True, false, true for the right-hand side. All right. So that means instance of does not depend on the static type. It depends on the dynamic type. How do you know the dynamic type? You got to keep track of that by yourself. That's why drawing diagram really helps. Any question about this? Okay. One more thing to mention. Okay, since I'm just now right on the diagram. Yes, go ahead.
If the answer of the instance of is true, then we can.
You can safely cast that into it. Yeah. Very good question. Yeah. So why are we doing instance of? Okay. The reason is you can also look back to the slides. It's because if you don't really do the instance of check, you might run into class cast exception at the runtime. If you do it, you can get away from that. For example, let's say over here, I can say if SMS.SS0 instance of students, it will be true at the runtime. That means I can safely cast this particular object expression over here into students. Right? I'll write it down. I'll just write one for you. For example, let's say let's write the one that's false. Okay, so I can say if over here SMS dot SS position 0 is an expression here, instance of. Okay, it's a keyword in in Java, and then I would say non-resident students. Okay, I would say if this is true at the runtime, I can do the cast. I can simply say NRS. I would say NRS is assigned to SMS.SS0 cast into NRS. Okay, so this part here is exactly the type we want to cast into, and we just check that. Now, however, at a runtime, this expression over here, as we agree, which is exactly the third case over here, is going to be at runtime false. False. If it is false, we don't even get a chance to execute this line. That means we wouldn't run into the class cast exception. Okay? Yeah, that's why you're doing instance of check. You should do it every time you try to do a cast. Even if sometimes you're so short, but it's better to do it as an assurance. Yes?
And you're just checking the objects in an array. Can like debug also just tell you what the types are?
Can the debugger tell you what the types are for the object? Yes. If you try to run the debugger for your Eclipse, if you try to expand the objects, you will see the type over there on the right-hand side. Yeah, you will see that, yes. Yeah. You can also, let's see, for the debugger, you can run the expressions view, right? You can actually check to see the instance of value. It will be true or false, right? That's something you can try as well. Okay? Okay, any other question about this? You okay? Yes?
Just checking, is there better to use a try and catch?
So, try and catch block is not really going to be useful here. Basically, instance of is more like taking some precautionary action. Try and catch is more like when a disaster already occurred. What would you do? It's different. You rather not run into class exception ever by using an instance of, rather than saying, I'm just going to try it. If it does happen, I'm going to do something else. Not really. Yeah. Any questions? Are we okay? Okay. The next one would be, okay. The next one would be return values. Okay, so this one we already talked about, so I will leave that to you. Okay, the same diagram, okay, on the slides, just the same. Oh, one more thing to mention, I forgot, because I'm kind of just answering the question. Again, so what we are really having here is something called polymorphic collection of students. Let's try to understand what this term really means, okay? So polymorphic collection, what does that really mean? That means you have a single static type, but dynamically speaking, you have many shapes for that particular type. So what do I mean? Especially if you look at that, if you look at this particular position and this particular position 0 and position 1, we know that for position 0, the static type is students, right? That's what we said before, students. And for position 1, the static type is also a students. But dynamically, you can see that over here, the object is being pointed to. Over here, the dynamic type for the first position is resident students. But for the second position, the dynamic type is non-resident students. That's what polymorphic collection really means. When you declare the type for the collection, you want to try the superclass, like a students. But when you actually insert stuff into the collection, you have many choices, as long as they are descendants of the static type. Okay, that's polymorphic collection. All right, let's now go a little bit further to talk about return values. Okay, return values is also following the same idea. Again, you want to talk about what's the static type, and then how you can assign things dynamically to it. Okay, let's see how we can do it. So let's say we have this. We still got our student management system. And then we have as students, the same as before. So now let's just say we focus on this version here, where the parameter is simply as generous as we can, the top of the hierarchy, just students. Okay? Now, let's consider a new method. I'll switch to iPad in just one moment. So now let's be very, very careful. When I say get students is an accessor, which takes index I. Basically, you just go into the array for the students and return whatever student object it is at that particular position. Okay? And then the return type for this particular method is students. That means any caller who's trying to call this particular method, all they can assume is the static type for the return value is going to be students. Okay, that's as easy as that, just declaration. Okay, now if I just switch to iPad and tell you, just write it down. So now over here, okay. So now we are talking about this particular method here, get students. Okay, so now you can think about the students over here is the return type. Return type, I would say static. That will be the static type for any return value that we are trying to return back to the any caller. Now, if the static type is actually students, dynamically speaking, what can be the object that's returned from this method? It can be any of the descending classes. It can be resident students. It can also be non-resident students. But how can this be implemented? Let's go over the code very quickly, okay, to see how you can do it. I'll just show you line by line. Now, first of all, let's declare, let's say we just make it easier for you. Let's say since I want to return a student's object, I just declare some local variable called, with student type. Eventually, I just return S over here, okay? And then I simply say from line number 6, I just do some error checking to say if the index is not valid, just throw illegal argument exception, okay? That's easy. That's not a focus for this particular example. Over here, I simply say else. If you look at line number 10, okay? Line number 10, is it going to compile? Line number 10. Line number 10 basically is over here. Is it going to compile? Oops, should be 2 times. Yes. Does it compile over here? Line number 10. Well, what is the static type for SSI? Students, as you can see from here. Okay? Static type is students. What is the static type for S? Also student, as we declare over here. So students is a descending class of itself. So that's going to compile, no problem. That's about compilation, okay? So I'm gonna erase that. Compilation-wise, it is okay. But dynamically speaking, what can be at position I? Well, as we learned from the previous example, also you can see from here, at position 0, oops, sorry, wrong hand. At position 0, if I happens to be 0, for example, we're going to return this particular objects where the dynamic type is actually resident students, right? If the I happens to be 1 over here, and we're going to return this particular objects, that'll be of a different dynamic type. Can you see the point here? The point is, the return type over here, yes, it's a static type, students. However, because the underlying array is polymorphic, that means at the runtime, depending on which position we are referring to, and also depends on which object is being pointed to by that particular position. It can be either resident students or non-resident students. In general, it can be any of the descending classes for the static type. Right? Let's try to go over some code quickly. So this one over here, I would say over here, SSI, I would say static type is just students, as we said. And the dynamic type can be any descendants of the students. Okay, that's what I meant. Okay, now let's go over the code together quickly. Okay, yeah, go ahead. Oh, when I say any descendant class of S.
What is the dynamic?
Where? You mean where?
S equals SS. So SS dynamic.
Oh, you're talking about the one I just wrote? Or you're talking about the line?
Right. What you just wrote is about SS, right?
Yes.
So how about S itself?
Oh, S itself? Oh, S. Yeah, exactly. So S is simply the variable we just declared, initially just null. So it depends on which object is being returned from SSI. S is just going to point there. But we don't know yet. Depends on the value of I. Right? You can see, yeah, let's go over the code. Maybe I think that will answer your question. Okay? So now, again, I'm just going to clean this board over here. And let's go over the code carefully. And then you will see exactly what I meant. Okay, again, this part of the code, we simply initialize this object structure here, over here. So that's the same as before, okay? Let me also clean this part over here. So let's see how we can trace the rest of the code. Let's see how we can do that. So now let's have a look at this line over here. I'm going to highlight it. Let's look at this line here. Okay? So now here we say students, oh, what? It may not be so nice a color to choose over here. So maybe I will just use maybe yellow. How about that? Okay, just that line there. So now here we got students S is assigned to SMS.getStudents at position as 0. Okay, just that. Look at that. Okay. Now, question number 1: is this particular assignment going to compile? If you think it's going to compile, I want you to justify that, right? If you want to justify the assignment is going to compile, look at the static type on the right-hand side. What's the static type for the right-hand side? How do you know the static type on the right-hand side of students? Where can you find it? Array decoration, are you sure?
On right-hand side, get students.
Well, okay, this is going to be careful, all right? So what you just said was, look at array decoration, that's wrong. It's not that, okay? If you look at the right-hand side, it's basically a method call, right? So we know that SMS is of type student management system over here. And then the get students method is exactly over here. And now to know the return value statically, you have to look at the return type students over here. So that's how we infer the static type for this particular expression is students. Guys, are we okay with this? This is something we haven't done so far. That's why I try to be more careful over here. Again, when we try to judge to see if an assignment is going to compile, the principle is always the same. Figure out the static type on the right-hand side, and then figure out the static type on the left-hand side to see if the right-hand side static type is a descending class of the static type for the left-hand side. Okay. Now, on the right-hand side, it's not like a single attribute access. It's actually a method call. If you have a method call over here, the only thing you can look up statically is to look at the return type. Okay. Now, this will compile, no problem. But now the question is, after this line, let's say after this line, I'll put a pink line over here. What's the dynamic type of S after this line? Resident students. Okay, that's a good try. Why don't we try all together? Okay, let's try. Okay, let's be very careful for the first one. Since we are trying to call this particular method over here, SMS, so which is this object over here, right? So we are going to execute this method over here, line by line. Okay, and the argument value is simply just 0. So we're going to replace, let me clean this part here. That means I'm going to replace I over here by just 1. Oh, sorry, 0. Just by 0. Okay, 0 is going to bypass this particular error condition, is fine. Now, what happened is we're going to have the following. S is assigned to SS at position 0. SS at position 0, well, it's a resident student. Okay? And we know that this guy over here, the dynamic type is resident students. That means after the assignments, S will also get the same dynamic type, resident students. And then we return this particular objects back to the caller. Okay? So that means you can think about the S over here is simply just going to point to this particular resident students objects over here. And when we return, we simply say the student, well, the name happens to be the same, but they're on different scope. Okay, just different scope over here. So S over here is just going to point to this object here. So the dynamic type is just going to be resident students over here. Are we okay with this trace? Yes.
So if we use that kind of declaration, student S, SMS, get a student.
Yep.
So we never get into a class cast exception, right?
You mean for class cast? Well, the thing is, there's no cast.
Yeah. Because always you're using, because the dynamic part is going to be same
Yeah.
as what.
Okay, let's clarify the misunderstanding here. So the question was, when I have this line that's in yellow over here, is it possible to get into class cast exception? I tell you why it's not impossible. There's no cast. How can you get to a class cast exception? right? It's a no-brainer, right? I can ask you that too, right? Are we going to get class cast exception for this particular line? No, there's no cast, right? So now, if there's no cast, think about why would you want to do a cast. When you want to do a cast, it simply means the right-hand side static type is not really a descending class of the static type on the left-hand side. If you want to really make the assignment to work, you have to do a cast. But in this case, it's okay, because you can see the static type over here is simply just students, which is already a descending class of the decoration over here. So we don't need a cast. So there's no way to get into class cast exception. Just not necessary. Right. We're okay with this? Okay. Now, let's go a little bit further. Let's now do some instance of check. Okay. So now we know that S over here is pointing to a resident students object. That means the dynamic type for S is now resident students. Let's try the following. Okay. First of all, let's try to say S this may not be so good. What about we simply say S instance of students? Would it be true or false? Because dynamic type, which is here, is a descending class of students over here, right? What about instance of resident students? Would that be true? Also true, because dynamic type, which is resident students, is also a descending class of resident students. On the other hand, what about this? When we say S instance of non-resident students, well, the same objects. Dynamic type hasn't changed just yet. And the dynamic type is simply resident students. Is resident students a descending class of non-resident students? No, so that'll be false. Okay? Now, one more thing to say. If I try S.get tuition over here, all right, is it going to apply the premium rate version or the discount rate version? Which version is it going to apply? Premium rate, how do you know? Yeah, exactly, because we know at this moment over here, the dynamic type for S is simply resident students. So that means it's going to apply that version there. So that's dynamic binding, right? Okay, symmetrically, we can do the same. Let's say this. We have the same variable S over here. Now, let me just highlight the line I want you to look at. Let's look at this line here. Compare the orange line with the yellow line. So what are we doing here? We're talking about the same variable S. Okay? In the orange line, we simply try to reassign S to a new value. So what value are we trying to reassign that into? We're trying to reassign that to the return value from SMS.getStudents at position 1. Right? That's the only difference. So now for that line over there, what's going to happen? Okay? If you have a look at that, now the argument value over here is 1, right? That means we're going to execute the same method over here, the same. But now the value for I would just be 1 in red. Let me just try to distinguish more. What about I just use green? Okay? So we're talking about 1 over here. So now I put 1 here. That means for this particular assignment over here, what I'm going to have is S is assigned to SS at position 1. It's a different position. So now what's the dynamic type for SS1? Non-resident students over here, right? That's at position 1. Okay, so that means over here, the dynamic type is simply non-resident students. And remember, S was static type students, so this will be okay assignments. And then, what would be the dynamic type for S after this? Just the same as that dynamic type, right? So that means after this, dynamic type for S would just be non-resident students. That means after this particular reassignment over here to get a return value when the index value is 1, rather than pointing to over here, S is now going to point to this particular objects instead, right? Now, if we try, let's just try here. If I say S instance of students, is it going to work? True or false? Well, because dynamic type non-resident students is a descending class of students. No problem. Now, what used to be false over here, used to be false in the previous one. This used to be false. But now we are checking the same condition over here. When I say S instance of non-resident students, it would be true. because now the dynamic type is simply non-resident students, which is a descendant class of itself. What used to be true over here, previously, if we try to run the same check over here, when I say S instance of resident students, is now true or false? Well, false, right? S is of dynamic type non-resident students over here, which is not a descendant class of resident student, right? So that'd be false, okay? So you can see the value for instance of does not, again, depend on static type. It does depend on dynamic type. And the only way you can know is by keeping track of the code. That's why I'm showing to you, right? Very carefully. One more thing before I conclude this particular example. When I say s.getTuition over here, just the same as before, but now, is this going to be the same version of getTuition that will be called? Or different version? Different version, right? Because you can see now, the context object S over here has the dynamic type non-resident students. That means it's going to call the version with discount rate. Okay? That's why you would just, whatever value it would be, you can do the math. Okay? Question about return value. Let me recap for you, okay, quickly. Whenever I give you any, when you see any question like this, when you look at the return type for a particular method over here, if that's a reference type, you have to be very careful about if the reference type has any descendant classes. If it does, that means dynamically, what's being returned from this particular method may be any of the descending classes for the static type of the return value over here. That's what we are trying to illustrate to you, right? And you should really know lines like this, why would it compile? You have to judge by looking at the right-hand side static type, for which you can just infer from the return type over here that's declared. But at the runtime, what would be the object that's being returned? You have to draw some diagram to really keep track of the things. Okay? There's no way around for you to figure out the dynamic type except for drawing some diagram, either on the paper or in your mind. Questions for this? Okay, good. Okay, now, one more topic for this particular slides, okay, for this particular lecture, and then we'll move on to abstract classes. Okay, now, I want to draw your attention again. So that's return values. We have already covered that, so that one's no problem. Okay, one more thing to talk about polymorphism, static type, dynamic type. So when to consider which? Let's make a conclusion here, and then we go to equals method, revisit. Okay? Static type versus dynamic type. As I said before 2 lectures ago, the principle is so easy. When you want to talk about compilation, whether a line of code will compile, you only look at the static type, nothing else. When you want to know if a particular method call or any assignments, how they would behave, or cast, how they would behave at the runtime, you have to talk about dynamic type. Okay? Okay, whether or not Java code compiles, you look at the static type. Okay? And then inferring the dynamic type, again, for those of you who are taking 2001, so keep this in mind. You will talk about undecidability. There are many computational problems, not so pleasant to talk about, right?
You just finished it.
I know, I know.
Yeah, I went with it.
Yeah, I feel bad for you, actually. Yeah. Anyway, seriously, yeah. Now, there are many problems in computer science that simply cannot be solved by writing a program. Keeping track of the dynamic type is simply just one of them. Okay, that's the only thing I want to say. Okay. All right. Now, when you want to talk about runtime behavior, especially which version of the method is going to be called, and also whether or not class cast exception will occur, you have to think about dynamic type. Okay? And then, best practice, draw diagram. Okay? Like what I did. So this slide here, I would say for those of you who like to be formal, that's exactly how Java Eclipse implements type checking for you. Okay? I wouldn't ask you to memorize it, but I would say all the principle we talk about, you nicely formalize it and also summarize it. Okay, let's not talk about it. You can refer to them. Now, let's talk about equals method very quickly. Okay, basically, I want to give you example very quick. Let's just go, this part over here, we already talked about when we talk about equals method. Okay, so equals method has some default definition for the object class. And the object class is this ancestor class for every class. in Java, right? I'll show you the scenario and then we'll go over the slides. I'll show you 3 different scenarios. Okay? Now, we know that there's a default version of equals in the object class, which will simply compare references. All right? Let's say we got classes A, B, and C. That's why you got A, B, and C over here. Guys, if you keep distracting my class, I got to do something about it, please. All right? Okay, so now, over here, let's have a look at the fragment of code over here. We got objects C1 and C2, and then they both have the dynamic type C. Okay? Let's have a look how we can look at that. My question is very simple. When I look at C1 dot equals C2, right? We know that the context object is C1. Okay? Now, does this line compile or not? So question number 1. Compile. Just apply your knowledge. If I ask you whether things will compile or not, you look at the static type. What's the static type for C1? No, yes, object, yes, correct. Sorry, yes. And does the object class have a equals method? Yes, indeed. Okay, so this will compile. Yes, no problem. Question number 2. Which version is going to be called? Well, it seems like, basically over here you can see in class A, B, and C, we don't declare any equals method, right? I simply say not overridden, not overridden, not overridden. Okay, so the only version that will be called is the version over here in the object class. So, object. That's easy. Let's see some comparison over here. Basically, the same example that I talked about, I modified that slightly. Okay, still we got A, B, and C. So now the only difference is I have overridden the equals method in class C over here. So now you can see that the same call over here, C1 that equals C2. The dynamic type for C1 is C. And now, it should be quite obvious to you which version should be called. Is it this version or this version? The version is C, right? Basically, the principle is the closest one. Okay, so this one here. That one is also not so bad. C. How about this? Well, this one is a little bit trickier, a little bit. The same, but now you can see we didn't override literally in C. We override in its parents. Now, if I say C1 dot equals C2, and then I got 2 versions to be selected, either this one here or this one here. Based on your intuition, which one should be selected? The closest one, right? Okay, very good. Let me just add some extra for you. Okay, you're right. You would simply choose the closest one, which is in B. What if I just do another one here? Boolean equals and objects obj, and then I do something over here. Which version? All right. Now, if I try to do Boolean equals over here, which version? Exactly, you got it. Okay, closest one. Okay, very good.
Can you go back to 2 slides back? The first one of the answer was object. Here we don't care about the dynamic.
We do, because, okay, thinking this way. Over here, we do have dynamic type over here, but now, since no ancestor has redefined or overridden the equals method, so we trace all the way back to this particular one. That's why, that's the closest one, if you like. Okay, so now, all you gotta do is in the slides, I just talk about the different cases. Either dynamic type itself overrides the methods, or somewhere between the dynamic type and the object overrides the method, or nowhere. Okay, just different cases. You can go over them. It's quite boring to go over them. Just read them all. One more thing about toString. The only thing I want to say, which I didn't really say if you took the 1022 with me, the only thing I want to say is something like this. So in 1022, we always talk about, let's say, system and out of print line. If I say system out of print line, let's say we have a let's say point class, right? Let's say point P1 is new. Oh, sorry, I did realize that. And then point, and then let's say 3 and 4. Now, let's say we did not override a toString method. By the way, toString and equals method, they're both inherited from the object class. So toString is also a very important method there. If I simply say P1 over here, okay, implicitly, it is as if you say print line P1 dot toString. As if. You don't have to write this as always like what we did in 1022. You can simply write this, given that you override the toString method. So when you go over the slide, basically it's trying to say, if you did not override the toString method, when you say print line P1, you will just print out the address for you. Okay? However, if you try to redefine the toString method, for example, over here, I simply just print out the representation for the point, x followed by y. In that case, after that, I will simply get 2, 4. Okay? It's a very easy concept. Okay? The only thing you have to remember is, when you say print line, you don't really have to say P1.toString. You can just say P1, given that you actually override the toString method. Yeah, you first and then them. Yeah. You mean, okay, so on the slides you will see that, yes. On the slides over here, I'll show you. In the beginning of that particular topic, you can see that over here. Okay, let me just show you here. Yeah, this one here, I can try to make it a little bit clearer. Basically, for this one here, I haven't really overridden the toString method just yet. That's why when I say print line P1, it's going to print out just the address. However, after that, when I do the overriding over here, that's after it. Oh, you don't need it. Override tag is only for the Eclipse to recognize if you have overridden it. As long as you follow the same signature for the method, you'll be okay. Okay? You got a question? That's your question, yeah. So the question was, do you need to add override tag? You don't really need it. Okay? Not really. All right. Yes?
Could you just quickly go back to the C1 and C2 example?
The C1, oh, you mean the equals method?
Yeah.
Yeah. Which one?
Anyone look. So what if you have a situation where pretend C1 and C2, they're different types, right? They're not both C, right? What if you have a situation where C1 C1 isn't overridden, and C2 is overridden?
Okay, good question. Basically, when you talk about this particular equals method over here, right? What type really is for C2 is not relevant, because which version of equals that is going to be called only depends on dynamic type for the context object, which is C1.
Okay.
Right?
And also, because you can use instance of, and you can also have like, so if C1 was like a B, right? You could have B equaling your C2, which is of type C, but not the other way around, because like A, B is not C, right?
Yeah. So
That's how you can handle a lot of like ambiguity.
yeah, let's say, yeah, for example, let's say this. Let's say, you know what, I'll just say new, let's say over here. I'll try to make it more concrete for you. Let's say for this, if I say point, and then P1, and then equal to something, like a new point, right? Let's say we already overridden the equals method like how we did before, okay? If I simply say P1 dot equals, and then I simply pass C1, which is defined over here, okay? This is going to compile, okay? However, remember one of the cases for the equals method that we taught. We say that if this dot get class not equal to other dot get class, and then we're going to return false. Remember one of the lines that we had to write. In this case, P1 is this, and C1 is other. So they are simply got different dynamic types, so you cannot compare them, right? So it should be false. This is a little bit more advanced, but I would say as long as you can know which version to call, that'll be enough. Okay, just the closest one. Yeah.
So with this example, let's say for instance we have B, which has an overridden
Okay,
class?
let me do that first. You're asking to say if in the B case, I'll put it here. Let's say for B, we say so we have got equals here, yeah, and then?
And then you have, let's say, a D class function, so one more below C.
Okay, sure.
How do you know which one is the equals method and which would be equals?
Basically talking about, let's say, let me just make it cleaner. Okay. Basically, you're asking the following. Let's say we got objects, let me just, without drawing the box. We got objects, we got A, we got B, we got C, we got D, right? Objects definitely has the equals method. You're saying that, let's say we already got, let's say in B, the equals. D as well, okay? So now it depends on the dynamic type, okay? Let's be careful. Let's say if I say here, objects O1 is new, let's say new B. Okay, let me just give you several examples so you can see that. O2 will be new C. Objects O3 will be new D. Okay, so now if I say O1 dot equals O2, okay, which version will be called? B, right? Only thing you have to look at will be dynamic type, which will be B. So that means it will be this version over here. On the other hand, if I try this, O2 dot equals O1, now which version will be called? Also B, right? But now think about why. The reason is a little bit different, right? If you look at the dynamic type over here, O2, the dynamic type is actually C. C itself does not have the equals method overridden, so go to the closest one, which is still in B. Okay? One more. What about if I say, over here, if you try to look at here, let's say O2 dot equals O3 versus O3 dot equals O2. Let's try these two. Okay, that'll be more interesting. Okay, let's call that 1 and 2. For 1, which version will be called? Okay, for 1 here, again, look at dynamic type, which is C. So that means C, no problem. Okay, what do you mean call the version in B? Yeah. What about number 2? D, right? Dynamic type is simply just D. So it will simply call the version in D. Right? Again, depends on dynamic type. Yeah, I know it's quite a bit, you know, try to get used to it. Yes.
When you talk about the equal method from the object class,
Mm-hmm.
In the part of the get class method,
Mm-hmm.
we're talking about the dynamic type, right? We're comparing the
Dynamic type, yes, correct.
Not
Not the static type, yes. Okay, any more questions about equals? Let's spend, I'll let you go earlier today. How about just another 5 minutes? Okay, another 3 or 4 minutes, okay, and then we'll, so another 3 or 4 minutes. Yeah, I'll take a question a bit later. I just want to introduce you to one problem over here quickly. So the plan will be, I will briefly mention the problem we're going to solve. What I will do next week, we're going to go into recursion, which is also an important topic. Okay, I will do recursion for about 3 or 4 lectures, and then we'll come back to inheritance. But let me just do one thing. At least we should really make use of the time well. Okay, just a few minutes. Now, let's consider a problem over here. Okay, now at least I can make the slides available. You can do some self-study. Nothing will be new to talk about polymorphism and dynamic binding. Everything about abstract class and also inheritance, we can apply exactly what we have learned. Okay? Now, let's consider a problem over here. So what we have is, we have, let's say, a polygon over here, may be either a triangle or a rectangle. From this hint, you would know you have to have a polygon superclass and also triangle, rectangle as the subclasses. And now let's say we want to do the following operations. Let's say we may want to grow the shape by incrementing the size. Let's say it used to be 3 by 4. I will grow that to be 4 by 5, right? And also, I want to calculate the parameter, the length of the sides, and also return the area. Now, question for you. Is it possible to get just a single definition of get area for both triangle and rectangle? Is it possible?
Yeah.
How would you do it?
No.
No, not really, right? Well, at least I know to get a rectangle area width multiplied by length, you cannot do that for triangle, can you? No. Different formula. On the other hand, for parameter, is it possible to apply a same formula for basically triangle and rectangle? Let's say the way we store the length for triangle, rectangle would be just using an array. In the case of rectangle, you got an array of size 4, right? If you have a triangle, you got an array of size 3. Can you have a same method definition for calculating the parameter?
Yeah.
How would you do it? Well, go over the array, sum up the sides, right? So that seems like for some operation, we can define them as common for both descendant classes, like getting the parameter. For some of them, like getting area, you need to apply different different formula. So now, in the case of triangle, have you heard about Heron's formula in your math class? Oh, okay, some of you did, but anyways, okay. There's a formula that can be applied to any triangle, okay? Basically, the whole problem over here is going to see how we can use abstract class so that some methods can stay as implemented, like a get parameter that can be shared by both descendants. But some method, like a get area, will stay as abstract, which means we just cannot implement them just yet until we get to the triangle or rectangle level. Okay, but we'll continue with this after the lab test. For lab test on Monday, okay, so guys, you pretty much know what my expectation is, right? Since we go so thoroughly on inheritance, be prepared for that. Okay, but the idea about abstract class is not covered. Okay, just that part. All right, see you.
Never seen that before.
Abstract class.